Today what we're going to talk about is inequalities. This will be short, it'll be sweet. I don't think you're going to have a problem with it. Think back with me to number lines. Tara, when we had a number line, we emphasized the idea of putting the variable on the left. The reason that we did that, Luke, was when the arrow points left, we shade left, so long as the variable's on the left. Remember that? Open circles versus closed circles. What caused an open circle? Someone remind me. Less than. What caused a closed circle? Okay, the equal to's. Okay? A closed circle means you include that point, Jalon. An open circle means you go up to it, but you don't include it. Remember those ideas? All right. That's what we're doing today, except instead of on a number line, Katie, we're going to do it on a graph. So, a little review. This is a good review for us right now because we're going to review actually for the graphing portion of the quiz today. We want to make sure all our equations are in y equals mx plus b form. Okay, this is crucial. You got to be in that form. Couple things to remember. If you divide by a negative, remember when we did divided by a negative? When I say change the inequality, what do I mean? Brett? Flip the sign. So the less than becomes a greater than. The greater than might become a less than. So it just kind of reverses. All right. It says if the inequality is less than or greater than, and the line is a dotted line and not part of the solution. You remember less than or greater than used to be an open circle? Oh, an open circle on a graph, Abby, is a dotted line. So remember how an open circle we went up to the circle but we didn't include it? Imagine going up to a line but not including the line. That makes sense? And then an equal sign is going to be a solid line. That means we go up to the line and we include the line. So, shading. This is the really simple part. If it's less than, we shade below. Okay? Always think below. And actually, I'm going to cross out to the left and to the right because that's actually confusing to some people I found last year. If it's greater than, we shade above. So, as I look at this line right here, I have section A and section B. Is this above or below? B. That's above. And A is below. I guess I should have put the A on the top, meaning above. But I didn't. Oh well. Anyway, so above versus below. All right, let's look down here at number 1. What's that?
How would you get a dotted line on the graph?
If it's less than or greater than but not equal to. Yeah, it'll be really straightforward. All right, I'm going to do a little sketch here. And then we're going to actually solve the problem. Little review. What's the y-intercept? 0, -1. What's the slope? 1 over 1. Remember when there's just an x there, it's 1 over 1, so go up 1 over 1, up 1 over 1, up 1 over 1. I'm going to make a dotted line here because it's not equal to. And you see how this says greater? That means all the answers are the answers that are above. Now, section A, right here. Where's that when you consider? That's below. So that's not the answer. What do we want? The upper section. All these areas up here. Now the key here, Kyle, is to, when you shade it, to shade all those areas, but don't have your shading touch the line. We want to go up to the line, but what? Not include it. So don't touch the line when you shade. So now we have to answer the question. 3, 8. Is that in the shaded section? Hard to tell. I don't have a grid here, Luke. But if it's in the shaded section, it's part of the solution, right? So I have to figure out how do I do this if I don't know if it's on a graph. Well, what I'm going to do is I'm going to take my equation and I'm going to plug in my numbers. 8 for y, 3 for x. And now I answer the question. Is that true or false? That's true. So if that's true, what does that mean about the point? Where do you know it's going to land? In the shaded section. So let's see. What's the question? It says determine if the point is a solution. So I guess we would have to say yes, it is. Anything in the shaded section is the solution. So this is what you do when you can't really tell from your graph, because 3/8 is somewhere up here, right? And I'm not sure if it's on the top or bottom. Well, now I know it's in the shaded section. Do you think we need to graph these to figure this out? Or can we just do the algebraic way? Just do algebraic. Question, Josh?
When you started at -1, you went up 1 and over 1.
Yeah?
So, if you went up 1, oh wait, when you go over 3, you go up 8 from there.
You go over 3 and up 8.
Okay.
But my problem is my graph isn't that big and it's not that detailed. But I was just trying to show you with the sketch the basic idea of what we're doing. So I don't even want to graph this next one, Brad. I'm just going to try to figure it out. Do we think this point 1, -4 is in the shaded section of this graph? Well, all we need to do, Sam, is just plug it in. -4 less than 2 times 1 plus 3. -4 less than 2 plus 3. Is this true or false? So what can you tell me without graphing? Where is this point? In the shaded area, right? Is it a solution? Yes. So long as this is true, that's a solution. So I guess we should say, yes, it is a solution. Pretty straightforward? All right, moving on. Practice graphing. Noah, this is great for the quiz today. On each one of these, we need an M and we need a y-intercept. Who feels comfortable giving me either one of the two? Jalan, go ahead. Okay, I need a number in front, please. What's the number in front? What -3? 0. Okay, so everyone plot 0, -3. All right, who can give me my slope? Go ahead, Luke. 1 over 2, excellent. So everyone go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Now don't draw the line. Just stop right there. Now we need to analyze. Are you okay there, Noah? All right. Is this problem equal to or just greater than? It's just greater than. So, we need to highlight that idea. Because it's just greater than, we have a dotted line. So, make a dotted line. I like to just connect the dots like that. Put your arrows on it. So now we have the line. Does that mean the line is part of the solution? Or is it just a boundary? It's dotted, so we go up to it, but we don't include it. Now the question is, where do I shade? To figure out that key idea, I look at the sign. It's greater than. Greater than means we shade above. Above. So, shade above. What'd you do in class today? Oh, I just colored. It's okay, Mom. I did numbers too. There we go. Can anyone tell me a solution to the problem? Look, Josh. -1, 2. -1, 2. I would agree. Can anyone tell me something that's not a solution to the problem? -5, 3. Sorry. That's a solution, right? Why? It's in the shade. Try again, Luke.
Okay. 5 -3.
Sure. 5 -3. Very good. You just had them flipped, right? Good job. All right, moving over. Let's look at number 3. All right, same question. Someone give me the slope. Someone else give me the y-intercept who didn't do it last time. Drew.
Y-intercept is 0, 1.
0, 1. Okay, so everyone put a dot at 0, 1. Someone else, give me the slope. Go ahead, Haley.
-3/4.
-3/4. So that means I go, Kyle, down 3/4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. We go backwards. 1, 2, 3, 1, 2, 3, 4. Okay. Talk to me here. Solid line or dotted line? What do you think here? Why solid, Brett?
Because it's just.
Yeah, it's not just less than, it's less than and equal to. So make it a solid line. Who feels they know how to shade? Kyle?
You would shade below, or you would shade, yeah,
Below.
And
Why do you say below? Let's just emphasize for,
because y is less than.
okay. So below. All right, so shade below. Hey, can I touch the line?
Yes.
I can touch the line, so go all the way up and touch that line. Obviously don't go across it though. There we go. All right, Luke did a nice job last time. Someone else, give me a point that you think is an answer. Put your finger on a point that's an answer. Everybody, do it. Haley, where are you?
-40.
-40. Is she in the shaded? All right, where are you, Zach?
-10.
-10. He's in the shaded area. All right, now put your finger on a point that's not a solution. Kyle, where are you?
Which one?
You, Kyle.
3, 1.
3, 1. You bet. Not a solution. All right, that makes sense? If I took Kyle's point 3, 1 and I plugged it into the equation, would I get a true statement or a false statement?
False.
A false statement. And that's what the first section was. All right, down to the bottom. Y is greater than or equal to 2. This is a review. Y equals. Everyone go to y equals 2 and put a dot right there. Y equals 2. Y equals is a line that goes through the y-axis. So everyone, I need to think. Should I make a solid line or a dotted line?
Solid.
Why are you saying solid, everybody?
Because it's greater than or
It's equal to. Everyone make a solid line. If you think you know where to shade, raise your hand. Sydney? Above it. That's right. May I touch the line? Yes. There we go. All of those, how many answers are there? Thousands. Thousands of answers. We can't put down all the answers. Remember when you touched your pen to the sheet? All 25 of you had different spots. You can't write all these answers. And so the only way we can show the answer is to shade it. Because all of those shaded spots are answers. All right. Now this one is the one exception of the whole lesson. And even so, it's pretty straightforward. Question, Josh?
Yeah. When it's greater than or equal to, does that mean you put it above, or is that depending on where?
The greater means above.
Okay.
The equal to means solid. Okay? If it was just greater than, you'd still go above, but you'd be dotted.
And if it's less than, it's below.
Less than is below, greater is above. Equal is solid, not equal is dotted. All right, everyone put a dot at x equals -3. What axis am I on? So what kind of line do I draw? Good, Abby. Nice. Now, take a look at that equation. What's special about the line I'm about to draw? Its slope is undefined. Good. It's dotted. All right, nice job, Brett. So everyone draw a dotted line through that point. What does a dotted line mean? I'm going to go up to it, but Not touch it. All right, now here's the one exception. You know how I've said above and below every single time? This is the one exception. There's no above or below this. True? So what do you think you're going to do? Come on, be logical.
Left and right.
Left and right. Which one do you think is the above kind of idea, and which one do you think is the below? Sydney? Above is the right. Yeah, makes perfect sense. Think of the number line. Which are the bigger numbers? The ones on the right. Little numbers on the left. So in this case, where do I shade?
Left.
My right. Your left. Exactly. So shade left. Left is less. That's how I remember it. Left is less. I really like this lesson. It's just fun to shade. Is it pretty straightforward? So,
We're not allowed to touch the line though?
no, you shouldn't. It means you go up to it infinitesimally close, but you don't touch it. It's kind of like heaven in Christ, okay? We can do lots of good works, but will it get us there? No. We're called to do good works as an outpouring of our faith, but we can't get there. Christ is that solid line that lets us cross over. All right? So, all righty. Well, shout out to John, who's not here today. There's our assignment. How many homework problems do we have really quick? Can you tell?
7. 8.
8. Good call. Good call, Zach.